This is going to blow your mind. Welcome to the Science and History Archives channel's special mini-series covering the history of the entire world. This is the first of 4 episodes where we explore the birth of Earth from stardust to planet. Imagine a universe bathed in the faint afterglow of the Big Bang. This afterglow, known as the cosmic microwave background radiation, is a relic from the birth of the universe, a whisper of the explosive event that set everything into motion. Space is vast and dark, filled with swirling clouds of hydrogen and helium gas. These gases, the simplest and most abundant elements in the universe, drift through the cosmos, waiting for the forces of nature to shape them into something more. These are the primordial ingredients, the building blocks of everything we see around us. From the smallest grains of dust to the largest galaxies, everything began with these basic elements. Gravity, the architect of the cosmos, begins to work its magic. This invisible force, pulling on every particle of matter, starts to draw these gases together. As the gases are pulled into denser and denser clumps, over millions of years, these clumps grow larger and more complex, setting the stage for the formation of stars and galaxies. These clumps are the seeds of galaxies, vast islands of stars scattered across the universe. Each galaxy, a collection of billions of stars, planets, and other celestial objects, is a testament to the power of gravity. Within these galaxies, gravity continues to shape the cosmos. It pulls stars into orbits, forms solar systems, and influences the paths of comets and asteroids. It pulls together enormous clouds of gas and dust known as nebulae, each a swirling maelstrom of cosmic potential. These nebulae are the nurseries of the universe, where new stars are born. These nebulae are the birthplaces of stars, the furnaces where hydrogen atoms fuse under unimaginable pressure to form helium, releasing the energy that lights up the universe. The process of star formation is a delicate balance of forces, a cosmic dance that has been going on for billions of years. Our own sun, a rather ordinary star in the grand scheme of things, was born in just such a nebula billions of years ago. It is a reminder that even the most common elements, under the right conditions, can create something extraordinary. The story of our sun is just one chapter in the grand narrative of the cosmos, a tale of creation and transformation that continues to unfold. Stay tuned for the next episode where we will delve into the fascinating details of the final chapter. Remember to share, like, and subscribe for more cosmic adventures. Stay tuned for our special 4-episode mini-series, exclusively presented on YouTube by the Science and History Archives channel. Our sun began its life as a dense cloud of gas and dust within a nebula. These stellar nurseries are vast regions in space where new stars are born, filled with the raw materials needed to create them. This cloud, much like others scattered throughout the cosmos, collapsed under its own gravity. The process of collapse is triggered by various factors such as shockwaves from nearby supernovae or the gravitational influence of other celestial bodies. As it contracted, it began to spin faster and faster, like a figure skater pulling in their arms. This increase in rotation caused the cloud to flatten into a disk shape, a common feature in the early stages of star formation. The center of this whirling cloud grew hotter and denser. The immense pressure and heat at the core initiated a series of complex reactions, setting the stage for the birth of a new star. Eventually, the temperature and pressure at the core of this collapsing cloud reached a critical point. This critical point is known as the ignition temperature, where nuclear fusion can begin. Hydrogen atoms, forced together by immense pressure, began to fuse into helium, releasing a tremendous amount of energy. This process, known as nuclear fusion, is what powers stars and gives them their incredible luminosity. This marked the birth of our sun, a blazing ball of fire illuminating the surrounding darkness. The energy released from nuclear fusion counteracts the force of gravity, stabilizing the young star. But the story doesn't end there. The formation of a star is just the beginning of a complex and dynamic process. The sun's birth was a messy affair. The surrounding environment was chaotic, with turbulent motions and collisions shaping the nascent solar system. Not all of the surrounding gas and dust was consumed in the formation of the star. This leftover material played a crucial role in the next stages of solar system development. Some of it remained, swirling around the newborn sun in a vast disk of debris. This disk, composed of gas, dust, and ice, is known as a protoplanetary disk. This disk, known as a protoplanetary disk, held the seeds of our solar system, the planets that would eventually orbit our sun. Over millions of years, particles within the disk collided and stuck together, gradually forming larger and larger bodies. These larger bodies, known as planetesimals, served as the building blocks for planets. Through a process called accretion, they continued to grow, eventually forming the planets, moons, and other objects that make up our solar system today. The formation of our solar system was a complex and lengthy process, but it all began in a stellar nursery with the birth of our sun. This incredible journey from a cloud of gas and dust to a vibrant solar system is a testament to the dynamic and ever-changing nature of the cosmos. Within the protoplanetary disk, a cosmic ballet was about to begin. Dust grains, remnants from the nebula and the sun's formation, swirled and collided with each other. These collisions, initially gentle bumps, gradually built up larger and larger clumps of matter. Over millions of years, these clumps grew from pebbles to boulders to mountain-sized objects called planetesimals. These planetesimals, drawn together by gravity, continued to collide and merge, their orbits crossing and intertwining in a chaotic dance. One of these planetesimals, located in just the right place within the protoplanetary disk, not too hot and not too cold, would eventually become our home, Earth. As Earth grew larger, its gravitational pull increased, attracting even more planetesimals and debris, adding to its growing mass. Section 4, A Hellish Cradle, Early Earth. The early Earth was a far cry from the life-sustaining planet we know today. It was a world of extremes, a place where the very ground beneath your feet was in constant turmoil. It was a hot, molten world, bombarded by asteroids and comets left over from the solar system's formation. These celestial bodies crashed into the young Earth with tremendous force, releasing vast amounts of energy. These impacts released even more heat, keeping the surface of the young planet in a molten state. The energy from these collisions was so intense that it melted the crust, creating a sea of magma. Volcanoes erupted across the surface, spewing lava and gases into the atmosphere. These volcanic eruptions were not like the ones we see today. They were far more frequent and violent, shaping the landscape in dramatic ways. This early atmosphere was nothing like the air we breathe today. It was thick, dense, and filled with toxic gases that would be deadly to most forms of life. It was a toxic mixture of carbon dioxide, nitrogen, water vapor, and other gases devoid of free oxygen. The air was thick with volcanic ash and other particulates, creating a hazy, suffocating environment. As Earth cooled, the water vapor in the atmosphere condensed, forming vast oceans. These early bodies of water were the first steps towards creating a more stable environment. These early oceans were likely acidic and bombarded by ultraviolet radiation from the sun, a harsh environment for life as we know it. The water was filled with dissolved minerals and chemicals, creating a primordial soup that would eventually give rise to life. Despite these harsh conditions, life found a way. Simple microbial life forms began to emerge in these early oceans, setting the stage for the complex ecosystems that would follow. These early life forms were incredibly resilient, able to survive in an environment that would be hostile to most modern organisms. They played a crucial role in transforming the planet, slowly altering the atmosphere and paving the way for more complex life forms. Over millions of years, these simple organisms evolved and diversified, leading to the rich tapestry of life we see today. The early Earth, once a hellish cradle, became a nurturing home for life in all its forms. Section 5. The Breath of Life. A hint of what's to come. The stage was set. Earth, a young planet forged from the remnants of dying stars, had cooled and formed oceans. It was a world teeming with potential, but it was still a far cry from the vibrant, life-filled planet we know today. Something extraordinary was about to happen, something that would transform Earth from a barren rock into a cradle of life. But that, my friends, is a story for another time. Stay tuned for the next episodes where we'll explore the rise of dinosaurs and the emergence of modern man. Don't forget to like, share, and subscribe for more fascinating content.